Okay, so we will continue with discussion of open source softwares and analytics. If you guys want, you can tweet me at Sivaj Gautam, and I would be able to take questions, and all the replays and demonstrations are also available on that handle. And let's continue with the all the open source software that are available in analytics domain. I would like to start with what open source is. It refers to a framework or a platform where people are able to share open source code and modify it. Basically, it is the design that is publicly accessible, that community can help to build, and community can help to grow and modify. So the basic term is it originated from like software development to basically designate a particular approach in order to create programs, computer programs. And the best value of open source is we are able to take the code out of the community, and we are able to develop it and modify it in a way that is most beneficial to our product line or our organization. And it's very transparent. There has been rapid prototyping models across it, and it's a community-oriented development. So it's always embraced and always exchanged with people. So it's a wide area for people who want to leverage open source in order to benefit their company. So the agenda of today's discussion is discussing Python. Python is one of the programming languages and associated libraries. So there are libraries associated to Python. What that means is basically when you have to make a program work as in make it achieve a particular task, then there is a code that we write. So that code, when we start writing it, most of the time we follow a class and object principle. And with class and object, they are defined under methods, functions, and those comprises of individual programs. So then there are programs that can be iterated or that can be generalized. Those particular programs are basically the libraries that you can associate with the programming language, and gives it an additional functionality that enables a programmer or developer to perform tasks which are not present as part of the programming language by itself. So it's very useful, and there are libraries like certain scientists, they want to use specific libraries for their scientific calculations. So it's very important for them to have all the components from those calculated perspective of scientific calculations, so that are not needed by a general programmer. So for those scientists, there is a separate library. In case Python, we would say it's SciPy. So depending on various needs, there are these libraries that are created. And then we are going to be discussing data science experience. Data science experience is named as data scientist who wants to have experience of, let's say, building a code, writing it down, and working on the go. Basically, when two people are coding together, they can share the code in real time. One can modify the code, and given the access, and makes it a rapid development approach to program or to perform data science operations. So, and then we would be talking about the best databases in analytics domain. Message bus. Message bus is basically when you stream data and you use a particular streaming method. So there is a buffer that you can apply to when you're using Kafka. Let's not confuse it. But message buses is basically when there's a stream of data coming in, and we want to have those messages onboarded and make sure that no message or no stream of data or packet is missed. So message bus ensures that. Database is where all your data resides, and there are different kind of databases. Some databases you can normalize. When I say normalize, it also means that you can put a structure around your data When I say structure, it means, let's say you have 10 calls coming on your phone, but then you want to structure them as with a serial number and with names and with those calls. So there's a particular format that you chose. That format goes into a particular database and stored in that format. So that's a structured database. Then we come to open source stack. It's a stack of all the frameworks combined together, put under a stack, and it's called an open source stack. Then we'd be discussing about IOP. So it's the IBM open platform with open source stack, so how it integrates and things. And then there's the open source foundation of IBM Cloud, that where we would discuss the application runtimes and frameworks. Bluemix is a platform where you can leverage all the frameworks all together under one login. And then we would surely be taking question and answers. So let's go to our first slide where it says open source based IBM Analytics offering. We have Apache Spark. It's a fully managed and resides on resilient distributed data processing services in the cloud, and it comprises of system machine learning, Tori, Jupyter notebooks, and Spark as core processing engine itself. So it's one of the heavily used analytics platform where a lot of companies are, taking help of Spark. They're building dashboards and they're able to process big data. It's a general engine to process big data very fast. It has built-in modules for streaming, and it offers around DAG execution engine that supports acyclic data flow, and it's in-memory computing. It's very easy to use and has around 80 to 90 high-level operators. So what does that mean is basically whenever you are building an application, you can parallelly build it, and it's very interactive. And how it becomes interactive is basically underlying it uses Scala, Python, and R shells. So the code is built on that. And then we can combine big data. That means chunks of data, which is structured or unstructured, and we can combine sequential query language with streaming and can perform complex analytics on it. So Spark SQL, Spark streaming, machine library, and then GraphX and Tori. These are different components of Spark. The Spark itself is a standalone feature or engine, a fast processing big data engine where you can derive meaningful inferences from large set of data. So when I say meaningful inferences, so that means, let's say you have 10 years old weather data. That data could be processed using Spark in order to figure out what is the weather going to be tomorrow. So approximate. What I mean by that is, it's going to process the data that would figure out, at that particular humidity or sensor device predicting a particular kind of condition at one point of time is gonna behave as a particular weather condition. So based on those patterns, we can figure out what is going to be weather tomorrow or today. We can do a forecasting as well. So it's just one example where this data can be used. It could be used, weather data forecast could be used for air traffic and for agriculture, a lot of areas where it could be used. And then there are a lot of contributors in Apache Spark, IBM being among the top, and there are libraries that does a outstanding job, and comes from a Java and Python background, where we are able to code and build applications parallelly and on big data. Another thing is IBM Open Platform with Hadoop and Big Insights. What does that mean? Is basically, there are concepts around in the market that talks about data lake, data reservoir, data swamp. What all that is basically, every second there are hundreds and thousands and millions of sensors. Those are giving out tons of data. That data has to go somewhere. So that data, is going in a database, in a particular database. It's getting stored, but then is it normalized? Is it structured? That depends on the database admin and on the organization using that particular data. And most of the time, the reality is half of the data is not even touched. So half of the data goes onto a data store, but then onto a database, but then we have to pay for the data storage, and then we are paying for a storage and we are not even utilizing that. So in order to be successful, it should be minimum input and maximum output. So over here we are not even utilizing all of our resources, all of our data. So with big data lake and with big data concept, all that data could be landed onto one particular data lake. That data lake would have governance piece around it, but then governance piece has to come from an authentication service or from a trusted partner, or all those compliances have to be kept in according to all the legal mandates. So IBM makes sure to provide all that IIG governance and secure model. So it has endorsed the Big Insight. Big Insights is the Hadoop component of IBM, where when I say Hadoop components, basically a framework to solve different problems, but it is basically processing that data from data lake. And then big data, it's called big data because that data lake is huge, and it's built as per norms, it's architected as per need, and the most important part of data lake is you can store unlimited amount of data because it allows you to scale that data lake. So when I say scale, is basically think of it as just bunch of disks concept when you're able to add more storage to it, and depending on your needs. So it's when you say add more storage, it's basically distributed data storage. So if we read through the slide, it says distributed data storage and processing. So basically processing the big data onto distributed data storage. It is available on premises and also as a fully managed service. It could be on cloud, and that's basically a portion of Hadoop that comprises of that is termed as a Big Insights. And what all components we have, we'll cover in next slides. So now going to data science experience. So data science experience has different components to it: Spark, Jupyter, Python, R, Scala, NumPy, SciPy, and scikit-learn and Pandas. They're libraries, and TensorFlow. So TensorFlow is basically a machine learning library. It allows you to perform a lot of functions that helps a program to learn certain specific tasks that it can serve as a ML library for your data science experience. It's very popular. Pandas is another library under Python, enables you to perform a lot of tasks. Scikit-learn is one of the other tools that helps in machine learning. SciPy is basically a Python library for scientific calculation. NumPy is for statistics, another library. Scala is a language. R is also a language where you are able to perform better visualizations. Python is a programming language. Jupyter notebooks is an interactive platform to basically build out your programs in small pieces, in small lines of code. And Spark is an execution engine. What data science experience does is it becomes a social workspace for all the data professionals. When I say data professionals, it would be all the developers and scientists. They could create and collaborate on their project. So basically, you can take the code from Scala. You can start writing code over there. You can collaborate with another Python developer in your team at the same time in the real time, and then can leverage another programming language or library in order to integrate to that code written in a particular language and perform different tasks and complete your projects onto building out anything related to your data. So very, very, very effective approach in order to collaborate in real time and work on your products. There have been instances when teams are struggling in order to verify and put their code onto emails and then to share it on let's say a particular box folder or a SharePoint, and then copying it to another, and then copying it to their platform, and then having integration issues, and then a lot of time was wasted in coordinating these tasks. But data science experience actually helps you, provides you a platform where you are able to do rapid development of your software, or of your programs, or complete your projects. So very efficient in saving time, improving performance, and collaborating in real time. Provides you a varied set of tools and languages to coordinate and collaborate and share and create. Then we would look at the open source based analytics offerings. So among those, there's Cloudent as a NoSQL DB. What does that mean? Is basically it's a database where you can have all the data structured or unstructured, and it's fully managed. So CouchDB is a part of it, and it's basically a database that has a specific set of layers, and it's very good for all the mobile applications that we create. Going to Message Hub, there is this Message Hub. It's also fully managed and has a high throughput because it's using Kafka. Kafka is basically a buffer system where you are making sure that so think of it as Kafka as a tap. So let's say it makes sure that water goes out if water comes in. What does that mean? It's a buffer. So once there is a message in, then only there is a message out. So that way you can be sure that you're not losing any information. So it's very important for making sure, let's say for a financial client, it's very critical to maintain the integrity of data and not to hamper the transfer of data or packet loss. So in order to avoid that packet loss, Kafka is the best suited message hub. So it's used in Message Hub and fully managed, gives a high throughput, and it's a message hub. Then we come to IBM Compose open source stack. Open source stacks covers in-memory caching, transactional data, all the analytics and data visualization frameworks, and also the config management tools with message queue. And when we talk about operational data, and which is mostly consistent and used for mobile applications, we're using MongoDB. MongoDB has varied set of features. Those itself needs a lot of attention, but it's a very good platform for storing data and follows a master-slave architecture. But it's very convenient to put data and process big data onto it. Then we have SkylaDB, which has another unique features. Then MySQL is another component of when you want to process transactional data. MySQL, PostgreSQL is very common. A lot of people are using it. and then rethink DB. So these are very strongly consistent systems and keep system of record. So then we have Elasticsearch for analytics, reporting, and data visualization. What it does is basically indexing data, and let's say when you have a lot of data onto data lake, you want to perform a particular operation on any set of data. So then Elasticsearch is something that would index all the data, whether structured or unstructured, respective, and gives you a edge on performing analytics. And you can also build out reports and perform data visualization using Elasticsearch. Very good component. That is how you keep track of all your data, and you're able to make meaningful inferences from your data. And then there comes in-memory caching. Redis is another tool for that. And then there's a message queue. RabbitMQ is used for message queue. etcd is one of the component of open source stack, where you can perform distributed config management. So these are the components of open source stack, and then there is this IBM Open Platform, IOP, also referred as IOP, with Hadoop open source stack. So basically all the components of Apache HBase, and then Solar as a search mechanism, can be compared to Elasticsearch, is Hadoop component, and then Scoop, Kafka being responsible for Scoop, Kafka, and Flume helping to move and migrate data, and then they yield Parquet or Avro or Snappy files. Those are very efficient file systems to store data and to move data, and maintaining the security of data using Apache Knox and Ranger, kind of authenticate, not kind of, but yeah, exactly, the authentication systems, and then using distributed programming, using Pig, MapReduce, SystemML, Spark. We've been evolving from MapReduce, from SystemML, and to Spark. So Pig is another language to perform distributed programming. And then, of course, cluster administration is done by Uzi. Uzi is an orchestrator, a tool basically where you're able to provide the notification and alert system, where you're able to look at the series of tasks that are performed on big data. And then Ambari and Zookeeper also being components of cluster administration, basically making sure your clusters are in good health, and nothing is down, no server is down, and you're able to perform processes, you're able to process the data onto clusters. And then doing resource management using Hadoop distributed file system, also abbreviated as HDFS, and Yarn as the resource manager, and then using Slider. And then there are different components. Solar can be used with Banana as a visualization tool. There have been times when we've been building dashboards using Solar. Solar is used for indexing all your data onto Hadoop. Hive being a SQL component of Hadoop, where you can trigger SQL queries and get results from your big data platform. So this is IOP with Hadoop open source stack. People might have been wondering a lot of times what are the components, how we do, what kind of data formats we are using, how we handle data in motion. So this slide basically gives you an overview of what all components are there in. And then there is a data preparation and integration service under the what are the uses of open source and what are the IBM analytics offering. So Data Connect is something that is where we have Spark as an underlying engine, and we are able to integrate and prepare data using Data Connect. So one of the great framework in order to prepare and integrate data with different components. So, and then there's a streaming analytics and IBM streams. So what does that mean is basically when you have a stream of data, ingesting it, analyzing it, monitoring it, and making sure that it's in real time. So those are the part of streaming analytics. So when you are analyzing all those components of streaming, it's called streaming analytics. And then Eclipse is one of the development environment for creating or building these applications on or streaming applications. And then there is another component called Zookeeper. Zookeeper is a framework responsible for coordinating all these services on these platforms, onto Hadoop. So and further going down to foundations of IBM Cloud is platform as a service and infrastructure as a service. Under platform as a service, there's Cloud Foundry, Docker, and OpenWhisk. And then under infrastructure as a service, there's OpenPower and OpenStack. So these are the two other components of IBM Cloud classified under platform as a service and infrastructure as a service. And then the last part of the presentation is the foundations of IBM Cloud and the pipeline tools that are also available in Bluemix. So Git is for source control. Eclipse is a development environment, and Maven and Gradle, those are build tools. Gradle is actually one of the most advanced application building tools and heavily endorsed by LinkedIn, Netflix, all the companies utilizing big data heavily and being a successful example. Gradle is one of the components that is heavily endorsed by them. It comes under the foundations of IBM Cloud. And then there is Jenkins for integration and Travis. And then there are XUnit, JUnit. Those are testing frameworks with Mocha and Selenium. And then there's log management using Logstash, Kibana, and Elasticsearch. So another components where you're able to track down or debug your program using, or create. In order to explain that a little more, whenever there is a system that needs attention or improvement, logs are the successful way of looking at what would be the next step, what could be the futuristic approach in order to improve the system. So that's when we can use Elasticsearch, Logstash, and Kibana components of software delivery pipeline tools in Bluemix and IBM Cloud. And then the application runtimes, we have Tomcat Server, we use ASP.NET, Node.js, PHP as part of web development, Ruby and Go as a programming language, Swift as mobile application development programming language, and then Python for language. And then there are web frameworks, Kichura, Flask, and Centaur. So this comes to an end, and we're still left with question and answers. If there are any question and answers around these tools, what they're doing, how they can be leveraged as the components where you are able to perform several tasks on cloud, or using big data, what components you want to leverage, what programs and what tasks you want to achieve, kindly feel free to send me a Twitter message or ask it at your convenience. So
Gautam, we don't have any questions. There is one request, but I'm not sure you had prepared that for this presentation in particular, and it's about seeing some examples in action, like seeing a demo.
Oh, okay, sure. Yeah, so this was just an introduction, and I would definitely do a demo, and I'm thinking of it making a meetup either in New York and also posting it onto a webinar. So we'll definitely do that for sure.
And also, if you go to our YouTube channel, which you should have the link on the email that confirmed your registration to the webinar, and we'll send it also again when we send out a copy of the slides and a link to the recording. There's
Yes.
multiple examples there from other webinars that we've already hosted.
Yes, yes. And then I do have it on Twitter handle as well. Like all those recaps are available, and I'm very much available almost all the times with a frequency of at least 24 hours. I would definitely get back in order to do an explanation or even do a demo if required. So not a problem.
Okay. Do we have any other questions from the audience? No, thank you very much. You will be receiving an email with a link to the recording and a copy of the slide deck. And it also has our Twitter account so that you can follow us and be informed of when we have new webinars, meetups, or hands-on trainings. And also a link to our YouTube channel. Thank you very much.
Thank you, everyone.